Welcome to the DIY Honda Garage channel. The DTC P068B, which stands for PCM Power Source Circuit Unexpected Voltage, means that there's a discrepancy in the power source circuit connected to the Powertrain Control Module, PCM, in the Honda Civic model years 2016 to 2021. The PCM, often referred to as the engine control unit, is crucial because it manages various engine functions, ensuring optimal performance, fuel efficiency, and reduced emissions. This code specifically points to an unexpected voltage issue, which indicates that voltage levels do not align with expected values under normal operation. The error could arise from several factors, such as damaged wires, faulty components, or poor connections within the PCM and relay circuit board. Understanding this code is essential because it guides technicians to identify potential failures that could disrupt engine performance. Correctly diagnosing and resolving this issue will ensure that engine management systems function correctly, preventing further complications. The error description for DTC P068B primarily involves the Powertrain Control Module, PCM, and its associated circuit components. The PCM is located within the engine compartment and is critical for controlling engine and transmission operations. It processes input from various sensors to optimize performance, but requires an adequate power supply to function. The relay circuit board, often found near the PCM, is responsible for distributing electrical power to various components, including the PCM. An unexpected voltage may suggest either a voltage drop or surge, which can occur due to several failings: a short in the power cables, poor grounding, or damaged relays. Early detection of this error allows for targeted repairs to avert severe engine malfunctions. The possible causes of DTC P068B include poor electrical connections, shorted wires, and a faulty relay circuit board. Poor connections can manifest as corrosion or loose terminals and may disrupt voltage transmission, resulting in unexpected readings at the PCM. Shorted wires may occur when the insulation degrades, allowing wires to contact each other or the vehicle's ground. This condition can lead to high current flow that disrupts the normal operation of the PCM. Additionally, a malfunctioning relay circuit board may not properly manage the electrical signals and power supply to the PCM, further compounding the issue. Identifying these problems in advance is key to an efficient troubleshooting process. Symptoms that may arise from DTC P068B typically include engine performance issues, increased fuel consumption, and the direct indication of the DTC on an OBD-II scanner. Engine performance issues could manifest as rough idling, stalling, or failure to start, all attributable to irregular communication between the PCM and other engine systems. Increased fuel consumption often follows because the PCM cannot execute fuel management strategies effectively when unsupported by stable voltage. Furthermore, the DTC appearing on a scanner will prompt further investigative measures, highlighting that the PCM isn't receiving proper power for its functions. Effective diagnostics is crucial in mitigating these symptoms to ensure vehicle reliability and efficiency. The first troubleshooting step involves verifying the problem by first turning the vehicle to the on mode, where ignition power is available without starting the engine. The Honda Diagnostic System, HDS, should be used to clear the existing DTCs. This action helps refresh the system and allows for new data to be captured. Following DTC clearance, turn the vehicle back to the off mode for at least 10 seconds before switching it back to the on position to check for any pending or confirmed DTCs again. If DTC P068B is indicated again, this indicates that the failure was duplicated, necessitating movement to the next troubleshooting step. If not indicated, It suggests an intermittent issue requiring checks for poor connections or loose terminals in the circuit. In the second troubleshooting step, the goal is to determine the possible failure area related to the PCM and relay circuits. Begin by ensuring the vehicle is in the off mode once more. The next action is to jump the SCS, Security Communication System, line with the HDS, allowing for a comprehensive voltage assessment once the vehicle remains in this condition for over a minute. Then, proceed to disconnect the PCM connector number 2, designated with 58 pins. With the connector disconnected, measure the voltage between two specific test points. Point 1 is terminal number 26 at the PCM connector, and point 2 is a solid body ground. If battery voltage is present, this directs focus toward further exploration of the system. If not, it suggests trouble further within the circuitry. The third troubleshooting step focuses on checking for shorted wires within the FI main RLI-CL line. First, disconnect the relay circuit board connector, C, which contains 18 pins. Following this, continuity must be checked between the PCM connector terminal number 26 and body ground. The vehicle should remain in the off mode during this process, with both the PCM connector and relay circuit board connector disconnecting. If continuity is detected, it confirms a short is present between the specified terminals, necessitating repair of the wire from the PCM terminal to the relay board. If continuity is not found, the FI main RLI-CL wire is confirmed functional, leading to the next troubleshooting step. In step 4, the focus shifts to checking the relay circuit board directly. This component is essential for managing electrical distribution to the PCM and other critical systems. Detach the relay circuit board to conduct a thorough inspection and testing. If the relay circuit board does test satisfactorily, the technician should look for any authorized service information that could be relevant to the symptoms or DTC causing concern. Alternatively, substituting it with a known good PCM may also be warranted. If DTC P068B clears post-substitution, replacing the original PCM becomes necessary to restore proper functionality. Directly testing this component is vital to ensure a comprehensive repair. The fifth troubleshooting step entails checking for shorts in the FI main RLY outline to power. Begin by removing PGM FI main relay 2, following by disconnecting the relay circuit board connector C. In this condition, voltage must be carefully measured between several points on the disconnected PCM connector and body ground. Specifically, test points include number 2, number 4, and number 6 of the PCM connector, ensuring the vehicle remains in the off mode. If battery voltage is present, this indicates a short to power in the relevant wire path, requiring appropriate repair action. Conversely, if no voltage is indicated, it confirms the wiring remains functional, pushing towards the next troubleshooting step. The final troubleshooting step requires another assessment of the relay circuit board. Removing and testing this component again is essential to ensure its reliability in managing the electrical distributions necessary for PCM operation. If the relay circuit board passes testing, the technician should explore any relevant authorized service publications pertaining to the DTC or associated symptoms. Should a known good PCM be available for substitution, testing after replacement should be executed. If the DTC P068B clears upon the PCM substitution, it is advisable to replace the original component, which suggests inherent issues within the original device. Completing these checks confirms that the vehicle's electrical system is operating without further complications. After completing the repair steps, it's essential to perform a final verification to confirm the resolution of DTC P068B. This step involves utilizing the Honda Diagnostic System, HDS once again to confirm that the DTC no longer appears in the system memory. After clearing any residual codes, a test drive is recommended to ensure that the vehicle operates smoothly without triggering the DTC again. This process helps validate the integrity of the repairs conducted, ensuring all affected components function as intended. A successful verification will affirm that the root cause of the issue has been identified and rectified, leading to reliable vehicle operation. To mitigate future occurrences of DTC P068B and similar electrical issues, adopting preventive maintenance measures is advisable. Regular checks of the electrical system, including voltage levels and circuit integrity, can help identify potential problems before they escalate into serious malfunctions. Inspecting connections frequently ensures they remain secure and free from corrosion or damage, critical to maintaining functional electrical pathways. Keeping components clean helps avoid the buildup of grime or dirt that can interfere with connections. Furthermore, scheduling periodic diagnostics can earmark emerging issues, allowing for timely repairs while keeping the Honda Civic performs at its best. To conclude, understanding the framework of DTCs, particularly DTC P068B, equips Honda Civic owners and technicians with the necessary tools to address power source circuit issues effectively. Implementing a systematic approach through detailed troubleshooting steps aids in diagnosing the underlying problems systematically. Proper execution of these steps can lead to successful repairs and an efficient vehicle performance restoration. Additionally, incorporating preventive maintenance practices can significantly reduce the risk of future failures. Emphasizing not just reactive repairs, but also proactive strategies ensures long-term reliability and peak performance for the Honda Civic from 2016 to 2021. Please like and subscribe to the channel. See you next time.